Okay, so number 36 is asking for the net force on each wire. And so what we want to do first is rewrite the system by drawing the wires like this, like a wire coming out of the page for wire 1, a wire going into the page for the second one, and a wire going out of the page for the third one. And now you have to figure out what the net force is on wire 1. So the force of wire 1 from wire 2, we use the right hand rule, and so this is the current's going into the page, and then we curl our fingers around the wire so the current is go clockwise, and it's going to go up through the wire like this. So that'll be the force or the magnetic field from the second wire. And then the third wire, its current or its magnetic field will be going using the right hand rule. The current's going out of the page and around the wire, so it's going to exert a magnetic field going down. That'll be B3. And we repeat this process for the second and third wire, and you'll get B1 going up and B3 going down. And for the third wire, you'll get B1 going up and B2 going down. And so we know that the force vector is equal to the current times the length vector crossed with the magnetic field vector. And to find the force of 2, you have to add the force of 1 on 2 and the force of, to find the force on force 1, you find the force of 2 on 1 and the force of 3 on 1. And you simply plug in these values for each one. And so for the first one, it will be, for the force of 2 on 1, it will be equal to 10 amps times 0.5 meters times mu naught 10 amps over 2 pi times 0.02 meters, because that's the distance between the two wires. And this equation comes from the magnetic field, which is equal to mu naught I over 2 pi d. And so that's the force of 2 on 1, and you add it to the force of 3 on 1. And since the force of 3 is going down, it's going to be a negative quantity. And you get negative 10 amps times 0.5 meters times mu naught 10 amps over 2 pi times the distance between the wires, which will be 0.04 meters. And you'll get 2.5 times 10 to the negative 4 newtons up. So that's the net force on the first wire. And on the second wire, since there will be equal magnitudes but in opposite directions, the net force on 2 will be 0 newtons. And you repeat the process for 3. So the net force on 3 will be equal to the force of 1 on 3 plus the force of 2 on 3. And you plug in your values again, and you'll get 2.5 times 10 to the negative 4 newtons J hat plus a negative 5 times 10 to the negative 4 newtons J hat, since the second, or the magnetic field due to the second wire is going down, and you'll get 2.5 times 10 to the negative 4 newtons down. And that's the net force on the third wire.